All right, today we are going under the hood of our favorite gadgets. No, not with a screwdriver, but, with a bit of knowledge. We're going to take a look at the tiny, almost invisible components that make literally all of our modern tech tick. So let's get right into it.
I mean, seriously, have you ever stopped to think about this? You plug your phone into the wall, and somehow that chaotic, powerful electricity from the grid gets perfectly tamed into this gentle, precise stream of energy your phone needs. It really does feel like magic, doesn't it? But it's not. It's just some incredibly clever engineering, and we're going to pull back the curtain and see exactly how it's done.
Okay, so before we get to the solution, we really need to understand the problem. And it all boils down to two very, very different kinds of electricity. Okay, so on one hand, you've got alternating current, or AC. This is the stuff that comes out of your walls. Think of it as wild and untamed. It's high voltage, and it's constantly flipping its direction back and forth. But then, you've got what your electronics actually need, direct current, or DC. This is the complete opposite. It's calm, it's stable, low voltage, and it only flows in one single direction. So right there, that's the fundamental challenge. Every single charger has one main job: to take that wild AC power and turn it into gentle, usable DC.
So how do they do it? Well, it takes a whole team of tiny electronic components, each with a very specific role to play. And they basically fall into two main categories, two families, if you will. So let's meet the team. First up, we have what are called passive components. The best way to think about these guys is that they're the basic infrastructure. They don't, think or amplify power, they just manage the flow. They can resist it, store it up for a bit, or release it. Super simple, but you absolutely can't do anything without them.
And then you've got the active components. Now these are the brains of the operation. Unlike the passive ones, they can actually control the electricity. They can amplify signals, they can switch them on and off. They're like the traffic cops or the gatekeepers. The one catch is, they need a little sip of power themselves to do their jobs.
So, just to quickly sum that up, passive components just kind of influence the energy that's already there. Active components can actually process it and amplify it, but they need to be powered on to work. For our little journey through a charger, we're going to focus on a few key players from both sides: resistors and capacitors from the passive team, and the super important diode from the active team.
All right, let's kick things off with those passive parts. I like to call them the unsung heroes, because they're managing the flow of electricity using some really elegant physics.
Okay, first up, the resistor. Its job is exactly what it sounds like. It resists the flow of electricity. The classic analogy is perfect here. Imagine water flowing through a pipe. A resistor is just like a skinny section of that pipe. It restricts how much current can get through. It's all about control, just slowing things down.
Next up, we've got the capacitor. Now you can basically think of this as a tiny, tiny battery that charges and discharges incredibly fast. Almost instantly. It sucks up energy and holds onto it in an electric field, and then it can release it in a flash. And that ability to kind of soak up and release energy is going to be super important for smoothing things out later on. You'll see.
And rounding out our passive team is the inductor. This one's a bit like a heavy flywheel. You know how a heavy wheel doesn't want to start spinning, but once it is, it doesn't want to stop? An inductor does the same thing for electrical current. It resists changes in the flow, which helps keep everything nice and steady.
Okay, time to talk about the active parts, the real brains of the bunch. And we have to start with the most fundamental one of them all, the diode. This little thing has one property that is just, well, it's what makes everything else possible.
So deep down inside, a diode is just two special materials sandwiched together. One side has a bunch of extra electrons that are just itching to move. The other side has a bunch of empty spots, or holes, where those electrons could go. And right where those two materials meet, they create this kind of natural barrier.
And here is the incredibly clever trick. If you apply voltage in one direction, the forward direction, that barrier shrinks down to almost nothing, and current flows through super easily. But if you try to push the current the other way, that barrier gets wider and wider, and it slams the door shut. No current gets through. And just like that, you've created a perfect one-way street for electricity. It's a game changer.
Okay, so we've met all the players. We've got our passive components managing the flow, and our active components acting as gatekeepers. Now it's time for the main event. Let's put them all together and trace the path of electricity from the wall, through your charger, and into your phone.
This right here, this is our map for the journey. We're starting with messy AC power coming in from the left, and it's going to pass through 4 key stages to end up as that perfect, clean DC power your phone needs on the right.
So, what are the 4 steps on our map? First, a transformer steps the voltage down. Then a rectifier gets the current flowing in one direction. After that, a filter smooths everything out. And finally, a regulator makes sure the output is absolutely perfect. Let's look at each one.
Okay, so this is what we're starting with. This chaotic wave is the AC power from your wall. See how it swings up into the positive and then down into the negative over and over again? It's literally alternating its direction. Our first mission is to stop that.
And this is where those diodes really shine. The rectifier stage uses 4 of them in a clever setup called a bridge rectifier. Think of it like a system of one-way gates. When the AC power is positive, it flows through 2 of the diodes. But when the power swings negative, the flow is rerouted through the other 2 diodes, which cleverly flip it around so it comes out going in the same positive direction. It's ingenious.
So what's the result of all that clever routing? Well, that whole negative part of the wave gets flipped upside down. So now we don't have alternating current anymore. We have what's called pulsating DC. Everything is flowing in one direction, which is great. But look at it. It's super bumpy and unstable. We're not done yet.
So, how do we fix that bumpy ride? Easy. We call in the capacitor. This is the filter stage. Remember how the capacitor is like a tiny fast battery? Well, it charges up at the top of each one of those bumps. Then, as the voltage starts to drop, the capacitor releases its stored energy, filling in the gap. It's like a little water reservoir, turning that bumpy path into a much, much smoother flow.
We are so close now. The power is pretty smooth, but pretty smooth isn't good enough for sensitive electronics. We need it to be perfectly flat and stable. That's the final job, and it belongs to the regulator. Think of it as the final quality control check. It uses some special components, like a Zener diode, to clamp the voltage at a super precise level, like, say, exactly 5 volts, and it doesn't let it waver at all. This is the clean, safe power your phone needs.
And that's the whole journey. We went from that chaotic AC wave from the wall socket all the way to pure, stable DC that your phone can safely use. And it was all done by this amazing little team. Resistors managing the flow, diodes playing traffic cop, and capacitors smoothing out the whole ride.
You know, every single piece of tech you use, from the simplest charger to the most powerful computer, it all relies on these exact same fundamental principles. It all comes back to these simple, elegant building blocks. And it really makes you think, right? If these basic components and rules gave us our entire modern world, what are the next building blocks going to create for us tomorrow?